VLSos here. This is a video lesson on point slope form of a line. I'm going to begin by making a precise graph. I'm going to highlight the coordinate 1, 2 with a point. I'm going to find where x equals 7 and y equals 5 and plot a point whose coordinates are 7, 5. I'm going to call this point A. I'm going to draw the line between these 2 points and show that it extends in both directions. I'm also going to highlight another arbitrary point on the line and plot its coordinates generically x, y. This point could be anywhere on the line. Lines have slope. Slope is an important feature of a line. A line's slope can be calculated as a rise or change in x divided by a run or change. The rise is change in y, and we divide by the run, change in x. This symbol is delta that represents the concept of change in. And of course, if we had the coordinates of the points or any 2 points, we could calculate the slope by finding the difference in y. Symbolically, we say y sub 2 minus y sub 1, and then divide by calculating the run, or the difference in x, by x sub 2 minus x sub 1. The slope of this line, since we have the graph, we could observe the rise and the run. In order to go from this point 1, 2 to point A at 7, 5, we rise by positive 3 and run by positive 6. I could use the coordinates of this point to calculate 5 minus 2 is the rise 3 and 7 minus 1 is the run of 6. In either case, we have a slope of 3 over 6, which we could reduce to 1/2. I'm going to calculate the slope between point A and any generic point xy. I could express that slope between these 2 points as the y coordinate minus 5, the difference in y between these 2 points, divided by the difference in x, or x minus 7. And when I do, I can see that I've calculated the slope numerically between these 2 points to be 1/2, and generically between this point and any point xy to be y minus 5 divided by x minus 7. And since these 2 calculations are both the slope of the same line, we could set one equal to each other and say that 1/2 is equal to y minus 5 divided by x minus 7. To help clean this up, I could solve it for y or solve it for y minus 5 by multiplying both sides by x minus 7. When I do, I can show the y minus 5 on the left by itself is equal to the other side 1/2 now times x minus 7. We can make note that this 1/2 was the previous slope calculation of the line. And the other parts of this equation are the coordinates of the point that I used in the second slope calculation. This 5 and this 7 are quite literally a point on the line. This here serves as an equation for the entire line because it has the x and y variables in it for a linear function. In general, we can write the equation of a line in this form that uses its slope and one point, any point on the line. In general terms, this equation is of the form y minus a y value from a point is equal to the slope times x minus the x value of that point. We could solve this equation for its variable y by adding the y component of the point used to both sides. And when we do, we get y is equal to m times x minus x sub 1 plus y sub 1. These two equations are both what we call the point slope form of a line. Because to create this equation, the equation for a line, we simply need to know what the slope of the line is and the coordinates of any single point. We have to be careful because x and y is used in a couple of different ways, that what we mean by x and y without little numbers by them are the true variables of the equation. And the x sub 1 and y sub 1, or any number, are values for those variables. And the reason, of course, why we would use x in both cases, but distinguish one from the other by putting a little number here, is because when it's a value, it is a value for the variable x. And when it's y sub n, that's going to be a particular y value for the variable y. There's another common form of linear equation we call slope-intercept form. And it's often the first abstract form of a line that students learn in Algebra 1, or maybe before. This is useful but it's more limited than point slope form, because in slope-intercept form you must know the y-intercept. The value b is the y-intercept. It's a particular point on the line. Where point slope form can use any point. The specific or particular value that you use for the x sub 1, y sub 1 comes from the x and y value of any point on the line. You only need to know one and its slope to create the equation.